What's up, folks? This is Mr. Walker here, coming to you through the internet, and we're talking about our next lesson. Our next lesson today is going to be dealing with congruent triangles. This is one of the two papers that we have, how it's going to look like after we fold it up. I'll show you it again after we finish going through and filling it out. So let's talk about it. All right, so this is the outside of it. These two sides here will be folded onto the inside of this, and this blank part, that's obviously where you're going to put the glue at. So let's talk about it. So first thing is, can I prove that these triangles are congruent? So if you remember congruent is essentially meaning, I'll scroll over here. Congruent is essentially saying that two things are the same. So if I have a right angle here and I have another right angle over here, these two are congruent to each other. Now, congruent means that they're the same type of shape, the same measurement, they're the same all around. They're like twins. So when we're talking about congruent triangles, we're talking about having the same triangle, just, it might be rotated around, changed around, but it is still the same thing. Okay, so you'll have one triangle over here, and let's say another triangle over here, and these two will be congruent in some way. Now, there's a couple different ways that we're going to talk about. We have about 1, 2, 3, 4, 5, 6. We got 7 different ways that two triangles can be congruent. So let's go through. Let's talk about it. All right, scrolling, and here we are. All right, so first thing you need to know, you only need 3 sets of corresponding parts to be congruent in order to prove that two triangles are congruent. Now, corresponding, just like how we were talking about back with corresponding angles and transversals, corresponding means that those parts are the same, just on the other triangle. So we just need 3 sets of corresponding parts to be congruent to say that these two triangles will be. So let's talk about the different types that we got. All right. First type that we got is if we have 2 triangles with 3 pairs of congruent sides. For this, we call this the side-side-side postulate, or SSS for short. So if I got 3 triangles and their sides are congruent to each other, that means that they are going to be congruent to each other. Yeah. So 3 sides, that works for us. All right, our next bit is if we have 2 pairs of congruent sides and the included angle. So when we're talking about the included angle, sorry about that, sneezed for a second. All right, so if we're talking about the included angle, that means that we're talking about the angle that's in between those 2 sides. So 2 pairs of congruent sides, so this side is congruent to this side is congruent to this, and this angle that's in between those 2 sides are congruent. And this is what we call the side angle side postulate. Now, when we're going through and looking at these, so far we looked at 2. You've noticed that we've had these little markings here. These markings indicate which parts of the triangle or which parts of the shape, if we're dealing with other shapes, are congruent to the other. So see the bottom here and the bottom here, they both have the same marking, which means that this and this are both congruent. Same thing over here with this side and this side and this and this. As well as for angles, if they're the same type of angle, they'll have the same markings around each other, okay? All right, now, get into our next one. We're talking angle, side angle. So what this is 2 pairs of congruent angles and the included side. So the side that's in between those 2 angles. So we got this angle is congruent to this angle is congruent to this, and this side is congruent to this, and this side is in between those. Has to be in these orientations so far for these to be congruent. So this is called the angle side angle postulate. All right, next one that we got 2 pairs of congruent sides of a right triangle. So this one is specifically for right triangles. If it's not a right triangle, this theorem that we're talking about will not work. This is called the hypotenuse leg theorem. So essentially what it says is, if we're dealing with a right triangle, like how we have over here, if the hypotenuse, which is the side that's opposite our right angle, and one of the legs is congruent, that means that the two triangles will be congruent. So if the hypotenuse and the leg are congruent, those two sides will, not two sides, those two triangles will be congruent. All right, next one that we got is the angle side theorem. So this is two pairs of congruent angles and a non-included side. So it'll look just like how the theorem says, angle side. We're looking at an angle, and then a side. Now see how these two angles here got different markings? That means that they are different. So this one and this one are congruent, and this one are congruent. This is so we don't get confused and think that we're talking about the same angles inside of their respective triangles. Alright, now we got two more left at the bottom that we're going to talk about. Now, this is cases that are not going to be congruent. So, this one down here on the bottom left, this is talking about side angle. If you have two sides and an angle, these aren't going to necessarily tell you that these are congruent, okay? This may not be congruent. Could there be other ways to prove that they're congruent? Yes, but for this would not be a good way. Likewise, you couldn't prove that two triangles are congruent if they have the same angles. You could have the same angles, but you could have different sides for those, okay? These would be a case for similarity, which is what we're going to talk about later on. Now, before we get on to some practice, one more thing that you need to know is a little acronym that we call CPCTC. So, let's type this out real quick, because this is kind of a mouthful of what it is. All right, let's zoom in here. So CPCTC. All right, now what does this actually mean? This is short for the corresponding parts of congruent triangles are congruent. Alright, so CPCTC is short for the corresponding parts of congruent triangles are congruent. I think you could start to see why we abbreviate this as opposed to saying this whole part of the sentence out loud. Now, what does that exactly mean? Let's look at two triangles here, okay? So let's say I have this triangle here, and we also got another triangle over here. Let's make this one red. Alright, so imagine I say that these two triangles here are congruent. This one is congruent to this because, let's say, this side and this side are the same. This side and this side are the same, and this side and this side are the same. So these two triangles are congruent based off of the side theorem. Now, along with these triangles being congruent based off of their sides, what we're going to know is that any other parts that correspond between these two triangles are also going to be congruent. So, looking at our two triangles, see how I got the sides here with two lines and one line? In between them, we got this angle here. If these two right here are on this triangle, the sides that match up are this top side and the side on the right. Now, if these two are congruent, that means that any of their corresponding parts will also be congruent. So, if this is equal to this, and this top part is equal to this angle that's in between those will also be the same over here, because there are the corresponding parts of each other's triangle. Likewise, this top part right here between these two should be equal to this angle right here. And this angle that we got over on this side should be congruent to this based off of this little theorem here. Now this theorem here is going to show up more when we start talking about triangle proofs, which we will next class, but right here, this is just one thing. Now I wasn't able to include it on the actual, note page, so I want you to put this in your notebook, either in the margins at the top or the bottom underneath where you put this in there. Okay?